Hi, welcome to Code.io. This is day 25 of 100 days of code, and the question for today is called remove duplicates element from a sorted linked list. Okay, we have solved a very similar question, like instead of a linked list we had an array, and the question was really the same. Duplicate elements, you have to remove it from the sorted array, and here we have to do it for a linked list. So the approach is quite different. Although the question is really the same, the approach is quite different. So we have a linked list here. I don't think I really need to read the question. It's quite obvious what you're going to do. So here we have an input, right? So we have a linked list which has 4 elements, 2, 2, 4 and 5, right? And now you're supposed to remove the duplicates from it. So the resulting linked list would be 2, 4 and 5. Okay, so we'll just draw a linked list structure, and that probably will help you understand this better. So 2, 2, 4 and 5, right? So arrows, this pointing to this, this pointing to this, and this will be a null pointer. Okay, so we are going to have a single pointer element which I'm going to name as PTR, right? So it is starting from the head node of the linked list, and you are going to see if the current value of the node is same as the next node's value. Okay, so you are going to see if the current value, which is 2, right, is same as the next node's value. You are going to see if these two are same. In this case they are same. So what you are going to do is that you are going to make the connection from the first node to the third node. Okay, so you are going to say that this first node is going to be connected to the third node of the linked list. So how exactly will we do that? You are going to say that ptr.next is equal to ptr.next.next. okay, so it will be the next of the next element. So this single line will make the first element point to the third element of the linked list, or in any case, like you will skip an element and point to the next element. So although you haven't eliminated the second node, it is no longer present in the linked list. Okay, so this 2 is going to be pointed to the element called 4. Okay, now you can just do the process again. You are going to see if the current value of PTR is same as the next node's value, which is 2 and 4, right? In this case you are going to see if 2's value is same as 4's value, and it is not. So when the values are not same, you can increment the value of PTR, or you can make the PTR point to the next node. Now PTR is currently pointing to the node with value 4 right here. Okay, you are going to do the same process again. You are going to see if 4 and 5 are the same. You are going to see the current value and the next node's value are same. They are not. So in that case you can move the PTR pointer, and you are right here now. And in this particular situation you cannot see if your current value is same as the next node's value, because there is no other next node present here, right? So in this case you can just end the iteration, and that is it. You can just return the linked list. So this is the basic thing. But we have one more case where we have like 3 elements combined together as a repeated node. Okay, so let me just give you an example. And okay, so let me just add one more node here, right? I'll erase all those things. We are going to add one more node at the beginning of this, which also has a value 2. Okay, what are we going to do in this situation? It's quite similar, the same approach, right? So we have our PTR pointer, which is at the head node, and its value is 2. You are going to see if its current value is same as the next node's value. They are the same. So in this case what would you do? You will disconnect this connection, and you will make it point to the next element, the element next to the next node. Okay, ptr.next equals to ptr.next.next. okay, so you have done this. But whenever you skip an element and point to the next element, you will not increment your pointer, you will not make your PTR move to the next node. That is not what you are going to do. You are going to just make ptr.next point to ptr.next.next, and that iteration is over. Why are we doing that? This is the example or the reason why we are doing that, because even the next node might have the same value as your current node, right? So if you try to move PTR whenever you skip an element, your PTR will be pointing here, and you will see if 2 is same as 4, okay, and it is not. So you will move on with the linked list and you will say there is no other duplicate nodes in the linked list, but we have duplicate nodes because the value 2 is present 3 times in the original list, right? So you are not supposed to increment, or you are not supposed to move the pointer PTR whenever you skip an element. You are supposed to move it only when you see that the next element's value is not same as the current element's value, right? So you have just made ptr.next equal to ptr.next.next, and you are going to do the same process again. You are going to see if your current value is same as the ptr.next value, and they are the same. So again, you are going to make ptr.next equal to ptr.next.next. In this case, it would point to 4, right? And it's quite similar. It is going to do the same process again and again, and it will end the list and it will return the list. So this is the logic. Hope you got it. Now we'll try to code this in Geeks for Geeks and see if it works. So here we are in Geeks for Geeks, and we are supposed to complete this method called remove duplicates, and we are given the head node as the argument, right? So I'm just going to create another pointer called ptr, and I'm going to make it point to the head node. Okay, done. Now we are going to traverse through this linked list, right? And I'm going to use a while loop for that, and the condition that I'm going to do is that ptr.next not equals null, okay, because we are instantly, like, we are comparing the next element's value with our current element's value for every iteration. So you should stop at the last one, right? So ptr.next shouldn't be equal to null. You cannot say that ptr not equal to null. That condition we cannot use it here, right? So ptr.next not equals null, and you are going to see if your current value, that is ptr.data, is equal to ptr.next.data. So you are checking if your current value is the same as the next node's value, okay? If they are the same, you are going to say that ptr.next equal to ptr.next.next, okay? This is the single most important line in this code, and we have already discussed why we are going to do that, okay? So this is the condition, and when it is not the case, meaning that the next element's value is completely different from the current element's value, you can increment the value of ptr, or you can move the ptr to the next node. So ptr equals ptr.next, and that is it. The code is quite simple, and at the end of the iteration you can just return the head node, okay, not the ptr, because ptr would have traveled through the list and it would have reached the end of the list. So you are just going to return the head. Now we'll run this and see if it works. The code is working fine, and all test cases have passed. Hope you understood this logic. If you have any questions, put them in the comments and I'll get back to you. And see you on tomorrow's episode of 100 Days of Code. Bye for now.